Now we will discuss about the SAR of the penicillins. Numbering already I told in the stereochemistry. According to the chemical abstract, we are giving the numbering in this way. Now see the importance of this moiety. Already I told in the stereochemistry, there are the three stereo centers are there, stereogenic center, third position, fifth position, sixth position, where stereogenic center, third, fifth and sixth. Remember that. These stereogenic centers are very important. How many should be there? 3 should be there. Any pen, if these three stereogenic centers are not there means no use. It won't have any activity. Remember that. That is the first rule. That stereogenic center also, that is in the form of 3R, 3S, 5R and 6R. This is already we discussed in case of stereochemistry. Okay. Then how many stereogenic center is there? 3 stereogenic center should be there to produce the good activity. First requirement is what? 3 stereogenic centers. That is the first. Next you might be observing, I will come next. First we need compositions. Compositions are sulfur and nitrogen, thiazolidine ring that will be attached to the beta-lactam ring. Okay. Along with it will be have the side chain with the amide. Okay. Amide linkage will be there here. This is very important. This skeleton is very important for the antibacterial activity. But in the stereochemistry we studied that it should be have 3 stereogenic center. It won't have 3 stereogenic center means no use of this one. Remember that. Then first point what we will be write? First point we will be write that basic skeleton, basic structure important. You can explain this one. Basic structure means what it contains? Thiazolidine ring attached to the beta-lactam ring, and it will be having the side chain at the 6th position, then ketonic group 7th position, acid group 3rd position, dialkyl group 2nd position, like this. Okay, you can explain. This is required for the antibacterial action with 3 stereogenic center. That is very important. Remember. This one nobody will be explained. Who knows chemistry well, that person only he knows about this importance of this stereogenic center. Now come to the first one. First what is there? First position sulfur is there. What we can do on the sulfur generally? We can do the oxidation. Oxidation means what it will be formed here? Oxidation when we will be do on this sulfur, it forms the sulfur dioxide like this. On this sulfur we are going to get the 2 oxygens due to what? Oxidation. This oxidation increases the stability towards the acid, means it is the acid resistant. Acid stability will be increases. Oxidation what it will be do? On the sulfur increases acid stability. It means due to the acid it is not going to be break down this structure. If it will be break down due to the acidity means no use of this structure. That's why if it is in the form of oxidation, if it is oxidized, acid stability increases. But the problem is that acid stability increases, but biological activity decreases. That's why what we are doing, any penicillin structure you can take, even though it is acid stable, but we are not oxidizing. Why? Means the action, antibacterial activity, it is going to be decreased. That's why we are leaving as it is in the form of sulfur, no oxidation. Sulfur, it is present in the form of sulfur only means producing the maximum antibacterial activity. Now you can see the next. What we are having here? Dialkyl groups. This dialkyl groups at the 2nd position also important. For what? Antibacterial activity. Remember, very important. If no alkyl substitution, no antibacterial action. No antibacterial action, or you can say less antibacterial action. But another thing is there, this one, you might be know. Lipid solubility increases. This is important for what? Antibacterial action. 2nd position you can write alkyl groups. Alkyl groups important for what? Biological activity. Not only that, indirectly it increases what? Lipid solubility. Then see the 3rd position. 3rd position acid group is very important because it is going to be bind particularly, it will be behave like the enzyme. Easily it will be attract towards that one. Then if this acid group, first what we have to write? Acid group very much necessary. Remember this, very much necessary. For what? Antibacterial act. If third position, if we do the reduction on this, what we will be do? Reduction. Reduction means acid group converted to the alcoholic group. Acid group converted to alcoholic group, OH group. Then what happened means it is completely going to abolish the activity. What they observed? No activity. It is producing the inactive molecules. No antibacterial action. That's why we have to believe this acid group as it. Then another thing, already I told, both these are trans to each other, opposite. Chemistry should be trans to each other. Which one? Amine group and as well as the amide group as well as the acid group. And acid. They should be trans to produce the better antibacterial activity. Fourth one, there is no substitution, nothing. Because already we saw in the mechanism of action, what we observed this nitrogen, it is this bond, it is going to be break for formation of the bond with the hydrogen. That's why here no substitution. If you do any substitution on the nitrogen, loses the activity, antibacterial activity. It should be in the form of tertiary only. Now see, in this case what happened? Fifth position, sixth position. Both the hydrogens are there. You can substitute this hydrogen. If you substitute this hydrogen, the action, antibacterial action, it will be going to be decreased. And another thing is that this fifth and sixth position hydrogen, both they are cis to each other, one side only. See, both are upper side on the dotted bond. Same side. What we observed there? Fifth and sixth position. What should be? Both the fifth and sixth position hydrogen cis to each other. They should be in the form of cis for the maximum antibacterial activity. And they should be stereogenic. Remember that. Okay. That stereogenic, how they are stereogenic, we discuss in the stereochemistry. Now we'll go for the sixth position. Sixth position, what I told, it will be having the amide linkage that is attached to the R. This R groups, it is very important compared to the entire structure. Means I am not saying this structure is not important. How much this all the structural component is important, it is equal to this one. Because entire activity or acid stability, either it may be degradation of the penicillin, everything, the stability of the penicillin, everything, it is depending on this one only. Sixth position, what? Not only it will be related to the activity variation, depend on the sixth position, stability, depend on the sixth position, degradation depends on the sixth position of this R group only. Remember this R group only. Okay, that's why that may be variation in the activity, stability towards the acidity, either it may be the degradation of this one due to any reason. Particularly, it is very important, this R group. Not only that one, this R group important for the beta lactamase enzyme. Remember this is very important. Otherwise what happened? This beta lactamase enzyme, it is going to break down the beta lactam ring. The name itself, beta lactamase, lactam ring is breaking down. This will be going to be break completely. Once it will be break, it will be remain in the form of penicillin? No. It means what? It is biologically inactive. No antibacterial action. That's why the R group playing the vital role for increasing activity, decreasing activity, increasing stability towards the acids, decreasing stability towards the acid, that may be degradation, that may be action towards the beta lactamase enzyme. What I told, beta lactamase, it is very dangerous for this beta lactam ring. That's why it have to be prevented. It have to be prevented means R group is important. Now I will show you which R groups are there. For example, generally you saw the benzyl penicillin. Benzyl penicillin R means what it will be have? Benzene ring, CH2. This is general benzyl penicillin. No substitution here. No substitution here. No substitution here. This is the plain benzyl penicillin. It is very prone to the, it is not resistant towards the acid. Acid unstable. Benzyl penicillin is acid unstable. Not only acid unstable, remember, it is going to be break easily. It means it is completely, it will become inactive. Because of this, here no substitution, here also no substitution. That's why the benzyl penicillin, it will be have the activity against the microorganisms, antibacterial action, but the problem is that it is unstable towards the acid. That's why it is called as the acid unstable. That is the reason. Okay, benzyl penicillin, it is replaced by the ampicillin. Next you can see R is nothing but CH NH. This is the R group. This is called as the ampicillin. Ampicillin, it is not resistant towards the acid, but it is resistant towards the acid. Because of what? Extra amine group. See how much it is important. This is not the acid resistant, but it is the acid resistant. It is stable with the acids. It won't undergo the degradation easily. Okay, that is the importance of this one. Still, if we replace this R group with 2-methoxy group like this is the R group. In place of R, it will be attached here. This is the example for the ticacillin. What it will be having? Two bulky groups, methoxy groups are there. This methoxy group, this ticacillin, this is the dimethoxy benzene. It is very important. For what purpose? Means to prevent for preventing which enzyme? I told one enzyme here, beta lactamase. It prevent this enzyme. How it will be prevent? When it will be attached here, it will be like this, come like this umbrella, and it will be protect this beta lactam ring. It will become like this umbrella, this. That's why it will going to be protect this. It means no breakdown of the beta lactam ring. Means more activity it is going to be produced. Understand? Not only ticacillin, you can take the naphacillin. Next is the naphacillin. You can see, I will write. Naphacillin means it will be having the naphthal here, OCH2, CH3. This is in place of R. In place of this R. Okay. This naphacillin, see here, this also having the bulky groups. It means it also going to be prevent which enzyme? Beta lactamase. Prevent the beta lactamase means it is no breakdown of the beta lactam ring. It means the activity will be remain like that. This beta lactamase is very dangerous. That's why we are taking the penicillins in the combination. Always. You might be heard beta lactamase inhibitors. That's why we are taking in the combination like sulbactam, tazobactam, monobactam, all those things. Now you can see not only this, in place of R, any heterocyclic moieties. Any heterocyclic moieties means like thiazole moiety, which is the dichloro. For example, you can see here, instead of methoxy group, if it will be having any chloro group, electron withdrawing groups, any electron withdrawing groups, this electron withdrawing groups also increases the active. If it will be having donating groups like amine groups and other groups like methoxy group, they are going to be protect from the beta lactamase. But when it will be having the electron withdrawing groups, they are going to increase the activity. These electron withdrawing groups are present in case of the different drugs like cloxacillin, dicloxacillin. I can write here cloxacillin, dicloxacillin. All they will be having the heterocyclic moiety in place of R, heterocyclic ring along with the halogens which are present on the phenyl ring. Okay, here heterocyclic ring also present, and as heterocyclic ring also present, as well as the halogens also present. It means it shows more protection for which enzyme? Beta lactamase enzyme, this beta lactamase. That's why it will be protect the beta lactam ring. See how much importance it will be have this R. And 7th position, as usual, this ketonic group is very important because already I shown in the mechanism in the last class. In the mechanism what I told, this carbonyl carbon only going to be bind with the transpeptidase enzyme, preventing the transpeptidase enzyme going to be bind covalently. That's why this is very important for binding with the enzyme. Which position? 7th position. Important for what? Binding to enzymes like transpeptidase. How it will be going to be bind? Already I shown covalently. Covalent bond it will be going to be formed. This is the SAR of the penicillins. I hope you might be understood. I given the lot of examples. Easily you can write even for 10 marks also. Thank you very much.